The second part to 4-2 is that there is a table to do binomial probability. So that being said, why do we have to use the formula when there's a table that does the probability for me? Because the table that we're going to use today in your book only does nice probabilities by a multiple of 5. So like 20%, 25%, 30, 35, 40. It doesn't do 62%. It won't do 1/3 probability. It only does multiples of 5. So we need the formula to calculate for those probabilities, but most of the time statisticians like to round to nice numbers, so that's why our table U has that. So you do need your book today, and the table is on A16, I believe. No, A8. A8 in your book, and I'm going to try to show you how to use this as best as possible. I know it's kind of hard to see, but when you look at the first thing to do is look at your table, and what you should notice on the top of your table here, it should say binomial distribution. That's how you know you're in the right spot there. And these on top, if you notice it has a P there, these are your probabilities. So if you notice, you have a 1%, 5%, 10, 15, 20, 25, 30, all the way across to 95. And then on the column here, you should see your N. And notice not every single N is on this table. If you keep flipping, it goes from 12 to 15 over here. And then it has one more page, 16 and 20. So your N isn't every single N either. And then your X, that second column, your X is kind of like your R. How many of those 2? How many of those 7? And so on. So let me try to show you here how this is going to work. According to an article, February 1991 issue of Reader's Digest, Americans face 1 in 20 chance of acquiring an infection while hospitalized. There's my P, 1 out of 20, which if we're using our table, 1 out of 20 is equivalent to what percent? 5%, 0.05. If the records of 15 randomly selected hospitalized patients, that's my N, are examined, find the probability that none of the 15 acquired an infection. Okay, that would be 0. So on my table here, I need to go to the second page and find 15. Here's 15, and I want 0 of 5%. So that would be 0.463. Everyone see where I'm at? 15. I need the 0, but I want the 0.05 column. So that'd be the second number over 0.463. And that's my answer. I don't have to do the formula. I can just look these up. As long as I know my P and my N, my R, I can look them up. So let's try this one. 1 or more of the 15 acquired an infection while hospitalized. So 1 or more would be 1, which is 0.366, or more would be all the way down to 15, okay? So if you notice, these are all zeros because the probability is so small that it's approximately 0. So 1 or more, I could go ahead and add 0.366 plus 0.135 plus 0.013 plus 0.005 plus 0.001 and add those up. Some of you might be thinking, why can't we just do the complement? And you sure can. That would be the other way to do it. I actually want, what's the opposite of 1 or more? None. And that is actually what we got in problem A. So I could do 1 minus 0.463, which would be a lot easier, but since we're using our table, it's almost just as easy to add those up. So either way you do it, you should get the same answer, 0.537. Okay. How about this one? Less than 7 acquired an infection while hospitalized. So less than 7, if you look here, less than 7 would be 7, which is 0% or less, and I'm going to go up all the way back to 0. And if you notice, all of this, if I did complement 7 or more, those are all zeros. So what should happen when I add these all up is that I get approximately 100%. And that's what I'm going to say, 100%. Because there is no such thing as a 100% guarantee. In statistics, we say approximately 100%. Like, it's really, really likely to happen. Okay, let's try another one. On average, 1 out of 10 boards purchased by a cabinet manufacturer is unusable for building cabinets. What is the probability that 3, 4, or 5 of the set 11 such boards are usable? Okay, so this changes a little bit. If 1 out of 10 boards are unusable, what's the probability that 3, 4, 5 out of 11 are usable? Well, in this case, my probability of success would be 9 out of 10. 9 out of 10 are usable. So I need the probability of 3, the probability of 4, and probability of 5, and OR means add. So I'd add those all up. So getting my table, n is 11. So n is 11, I'm looking right here, n is 11. And I want 9/10. 9/10 as a decimal would be, yep, 0.9, 90%. So I'm way over here, 90%, and 11, and I want 3, I gotta follow, 3 of the 11 would be 0, 4 of the 11 is 0, and 5 of the 11 are 0. Okay, so what's the probability that only 3, 4, or 5 out of 11 are usable? Approximately a 0% chance, and that should be the case, right? If only 1 out of 10 are bad, right? To only have 5 good boards would be very unusual. So we'd say 0, 0, 0, so approximately 0%. We're not going to say is 0%, we're going to say approximately 0%. That probably won't happen, right? If I have 11 boards, only 5 of them to be good probably won't happen, and that makes sense. Let's try another one. 90% of trees planted by a landscaping firm survive. What's the probability that 8 or more of the 10 trees they just planted will survive? So again, I'm at 90%, and 10 is my n, 10 total trees, and I want 8 or more. So 8 or more would be 8, 9, 10, and or means add. I'm going to add those together. So 90%, 8 out of the 10, 0.194, 9 out of the 10 would be 0.387, and 10 out of the 10 would be 0.349. So add those 3 together, 0.194 plus 0.387 plus 0.349 would be 0.93. 93% chance that 8 or more will survive. All right, maybe one more. An article in the Omaha World Herald stated that only 60%, there's my P, of the individuals needing a bone marrow transplant find a suitable donor when they turn to registries of unrelated donors. In a group of 10 individuals needing a bone marrow transplant, so there's my N, 10 people, there's my P, 60%. What is the probability that all 10 will find a suitable donor? So 10 of the 10. So again, my N is 10, but now I'm at 60%. So right here, 60%. And I want 10 of the 10 would be 0.006. What is the probability that exactly 8 will find? So again, 60%, 8 would be 0.121. What is the probability that at least 8 will find a suitable donor among the registry? So at least 8 would be 8 or more. And I already have 8. It's 0.121. I already have 10. That's the first one I did. So what I need is 9. So the 9 would be 0.04. Right, so I add those together. 7, 6, 1.167 then is my probability. Okay, what is the probability that no more than 5 will find a suitable? Okay, no more, here's a new one that we haven't seen. No more than 5 would be 5 or less. No more than 5. 5 is the max, the limit. So 5 or less would be, I would need 5, 4, 3, 2, 1, 0. Could you do the complement? Yes. That would be 6, 7, 8, 9, 10. And since I already have 8, 9, and 10, I would just have to do 6, 7 and add 6, 7 to this number. Or if that totally confuses you, that's fine. 5 or less, so 60%. 5 or less would be 0.201, 0.111. I keep losing my spot. 0.042, 0.011, 0.002, and 0. Add those together. 0.201, 0.111 plus 0.042, 0.11 plus 0.367. There you go. Okay, so your homework is in your book, but I am going to change it a little bit. I have to change the probability so you could use the table. Okay, so if you look in your book, on 4-2, so 4-2, page 211, you are going to do 15 through 20. Okay. But like I said, I'm going to change the probabilities. So on problem 15, you're going to use 60%. On 16, you're going to use 40%. 17, 25%. On 18, you're going to use 65%. 19, you're going to use 55%. And 20, you're going to use 70%. Okay, so this way on these problems, you should be able to use the table to find all the probabilities.